Hello and welcome everyone. In this video, we will do a brief introduction to Data Vault and understand why it started to become very common modeling methodology recently. But first, a little bit step back and get understanding what are the today needs and challenges. Data warehousing play a critical role for companies to enable them to access and analyze all of their data to derive the most accurate business insights and forecasting models. When it comes to data warehouse design, two of the most widely discussed and explained data warehouse approaches are the Inman method and the Kimball method. When we look at the diagram, 3NF model is adopted as data warehouse around 80s. Then in the mid to late 80s, dimensional modeling or star schema is introduced and started to become widely used data warehouse solution. It was architected to solve subject-oriented problems, including aggregations, data model structural change, query performance, reusable or shared information, and the ability to support online analytic processing. Both philosophies have their own advantages and differentiating factors, and until now, or even from now on, they both work quite well for each specific use cases. But over time, the needs of companies, business, or expectations are changed. We started to hear multiple buzzwords: agile methodology, big data technologies, real-time processes, digitalization, and along with that, the usage of data across the companies are massively increased. Therefore, we started to have some challenges or difficulties to store and manage data with existing data warehouse solutions. So let's understand these challenges a bit further. The business expectations are changing rapidly. Enterprise data architectures must be flexible and adaptable for fast-changing market conditions. But data warehousing with traditional solutions as 3NF or dimensional model take long time to deliver concrete results. And even the solution is in place, they are not designed to respond to fast changes. When a business system, structures, or rules change, data warehouse BI systems often involve significant construction effort, ongoing maintenance, and re-engineering process. When we consider the 3NF, we would encounter the following issues: parent-child complexities, cascading change impact. For example, when there is a change in the parent table, it needs to be rippled down through the child tables. And this dependency makes it difficult to extend and maintain an enterprise model, and would also have difficulties in real-time loading due to complex loading dependencies. For dimensional model, biggest challenge is to change the granularity of the fact table. If you would like to add one more grain, either we need to create a new fact table or modify the existing table. Those changes require complex ETL processes and can lead to changes on reports and applications, while in fact these changes might not be relevant to all of them. And another challenge is with the rise of internet and computers, we are able to capture data from each online interaction, like from social media, Internet of Things, sensors, mobile applications, in both structured and unstructured format, and much of them generated in real time at very large scale. Therefore, the data volumes in warehousing are growing rapidly. But traditional approaches are limited on here to capture, store, model, or perform data on this scale. And in here, Data Vault modeling helps properly address these challenges. Data Vault is a new design approach and invented by Dan Lindstedt. And the history dates back to 90s. In 2000, Data Vault 1.0 became a public modeling method. Especially between 2005 and 2010, it became well accepted. Data Vault 1.0 is highly focused on data vault modeling, that is to say, a dedication to physical and logical data models that construct the raw enterprise data warehouse. In 2013, Data Vault 2.0 was released and extends beyond the enterprise data warehouse to offer enhancements around changes to the model for performance and scalability, and following the Scrum and Agile best practices, and including NoSQL and big data systems and integration with unstructured and semi-structured data. Currently, multiple organizations have adopted Data Vault and have used it to develop their data warehouse. So, data warehouse, briefly described by Dan Lindstedt as detail-oriented, historical tracking, and uniquely linked set of normalized tables that support one or more functional areas of business. It is a hybrid approach encompassing the best of breed between 3NF and star schemas. The design is flexible, scalable, consistent, and adaptable to the needs of the enterprise. But actually, contrary to popular belief, Data Vault is not just a modeling technique, it is an entire methodology for data warehouse projects. The raw Data Vault is like an intermediate layer between 3NF and dimensional modeling, and that provides scaling with the growing business requirements and reduce complexities of the both modeling and ETL. Data Vault is mainly composed hub, link, and satellite tables. To simply define, hub represent business keys that are uniquely identified with a very low tendency to change, and link represents relationship between the hubs. And finally, the satellite include the descriptor attributes of hub and link tables, and it is consisting of data that tends to change over time. And why Data Vault is critical for organizations? Data Vault is an innovative data modeling methodology for large-scale data warehouse platforms. It was developed specifically to address agility, flexibility, and scalability issues found in other data modeling approaches. It was built to be granular, non-volatile, auditable, historical repository of enterprise data. The key benefit of Data Vault architecture is that it has a design that is flexible and adaptable to meet the changing needs of an enterprise. With traditional data models, it could take BI teams months to add new objects or relationships into the data warehouse, and it requires complex ETL processes. But Data Vault supports incremental delivery. So your system can go in small steps. It means you can start with a small production system up and running, then you can extend your model into larger one without changing the existing structure. So the popular agile approach to project management is very aligned with the concepts behind the incremental delivery of the Data Vault. On the other hand, we could have multiple source systems and relationships that change frequently. Data Vault works very well for the systems with these characteristics because it makes adding changes simple. If there is a change to only one source system, that change doesn't impact other source systems. And as a result, data model created using the Data Vault can scale according to the requirements of an organization and respond flexibly to the necessary changes. And Data Vault 2.0 incorporates very well integration with the big data technologies. And through this adoption, very large amounts of data can easily be incorporated into a Data Vault designed to store using products like Hadoop, InfoBright, MongoDB, or any other NoSQL options. And these technologies helps to ingest unstructured data like audio, video, and images as well. With the introduction of hash keys in Data Vault 2.0, data load dependencies are eliminated. Data Vault allows for parallelizations because the modeling approach has fewer points where data needs to be synchronized. And this results in faster data loading processes, which means real-time or near real-time data loading is possible in addition to parallel loss of terabytes to petabytes of data. And another significant point of Data Vault is Data Vault provides to easily track and audit your data. Each table in Data Vault enables auditing by including the load times and record sources for every row. When an attribute is updated, a new record is created, it tracks a history of all changes in the satellite tables. All of this auditing enables you to easily provide auditability for both regulatory and data governance purposes. Because you store all of your history, you can access data from any point in time. And another feature is while both entity relationship modeling and dimensional design require time and experience to build skills, Data Vault tends to easier to automate, and there are several tools to help deliver the solution. Please don't consider them in a way any recommendation, but here is a short list of the tools which can help to automate the delivery of the Data Vault. So if you would like to get further information, you can do a quick search in the web browser, and I'm sure you can get quite amount of data about these listed tools. Okay, we get an understanding about the important features of the Data Vault, but to simply summarize the benefits of the Data Vault, it supports flexible and agile approach. So it is scalable and enable highly parallel data loads. It covers and manages history efficiently, and because there is no updates or deletes on business data, it is fully auditable. And it also supports and combines relational database management systems and Hadoop NoSQL technologies, and that allows to work with different types of data, including unstructured and structured. And by this way, we can also handle extremely large data sets with both batch and real-time streaming scenarios, and can integrate Data Vault methodology in both on-premises and cloud solutions as well. And additionally, the model can also be optimized with multiple products in the market. So while there are many advantages to Data Vault, it does also have some drawbacks that must be considered as well. In Data Vault, source tables are normalized by distributing relationships, business keys, and attributes into separate tables. Therefore, the number of tables being created is high when compared to denormalized structures such as star schema. Result of Data Vault design, we end up even more tables, and it requires a lot of joins to drive data mars. Therefore, the performance of the load data mars can be challenging. And like 3NF, Data Vault is impractical for direct querying and to identify the correct version of data. And due to denormalized structure, it requires more storage in the disk space. There is not a single solution that would perfectly match for each data warehouse requirements, and it is also valid for Data Vault. So Data Vault modeling is robust and mature data architecture, but can only provide real value to an organization when it is used for the right use case. If you have a small to medium-sized analytics requirements with a small team of architects, designers, or engineers and delivering a solution with data source from the few systems, then Data Vault may not be suitable for your needs. Dimensional model may be more simplified way and require less data manipulation in that scenario. And furthermore, Data Vault requires a lot of more storage due to normalized structure. Distributing a subject area into 3 different tables, hub, link, and satellite, essentially increases the number of tables by at least a multiple of 3. For these reasons, a Data Vault model is not worth implementing if your data is straightforward, and the benefits mentioned before can be easily achieved through a more simple dimensional model. So it is important to take both the benefits and drawbacks listed before to help to choose whether a Data Vault approach is advantageous for your use case or not. Thank you for listening.